A potential issue arises when directly wiring a central vacuum outlet to an arc fault circuit interrupter, or AFCI outlet. These AFCI outlets are designed to trip when they detect a sudden increase in current, which often signifies a fault in the wiring. The direct connect current carrying crush-proof hose, commonly used in central vacuum systems, can generate a high inrush current when the vacuum is activated. This inrush current can be misinterpreted by the AFCI outlet as a fault, causing it to trip unnecessarily. This can be inconvenient, especially if the vacuum is used frequently. To avoid this potential problem, it is generally recommended to connect the central vacuum outlet to a standard, non-AFCI protected outlet. Let's delve deeper into the reasons behind this recommendation. An AFCI outlet's primary function is to protect against arc faults, which are dangerous electrical conditions that can lead to fires. These arc faults are characterized by unintended electrical discharges between conductors, often caused by damaged or deteriorated wiring. The AFCI outlet continuously monitors the electrical current flowing through the circuit, looking for specific patterns that indicate an arc fault. When it detects such a pattern, it quickly trips, cutting off the power to the circuit and preventing a potential fire. The sensitivity of AFCI outlets, while crucial for safety, can also make them prone to nuisance tripping. Certain types of electrical equipment, particularly those with motors, can produce transient current surges during startup. These surges, although normal and harmless, can sometimes mimic the characteristics of an arc fault, causing the AFCI outlet to trip. Central vacuum systems, with their motors and direct connect hoses, are particularly susceptible to causing these nuisance trips. The inrush current, which is the initial surge of current drawn by the motor when it starts, can be significantly higher than the normal operating current. This high inrush current can trigger the AFCI outlet, even though there is no actual arc fault present. In such situations, the AFCI outlet is simply doing its job, but in a way that is more disruptive than helpful. Connecting the central vacuum outlet to a non-AFCI protected circuit eliminates the risk of nuisance tripping caused by the inrush current. Standard circuit breakers are designed to handle these transient surges without tripping, allowing the vacuum system to operate normally. However, it is important to ensure that the circuit is properly sized to handle the load of the vacuum system. The circuit should have a sufficient ampacity, which is the current carrying capacity of the wires, to safely accommodate the vacuum system's power requirement. To determine the appropriate circuit size, consult the vacuum system's nameplate, which lists its voltage and amperage ratings. Use this information to calculate the total power consumption of the vacuum system. Then, refer to the National Electrical Code, NEC, Table 210.21 subsection B number 3, which specifies the maximum allowable load on a branch circuit. Make sure that the vacuum system's power consumption does not exceed this limit. In addition to ensuring adequate circuit size, it is also important to use the correct type of wiring for the central vacuum outlet. The wiring should be appropriately sized for the circuit's amperage rating and should be installed in accordance with the NEC requirements. Common types of wiring used for outlets include non-metallic sheath cable, NM cable, and electrical metallic tubing ENT. NM cable is a flexible type of wiring that is commonly used in residential applications. EMT is a rigid metal conduit that provides excellent protection for the wires. When installing the wiring, make sure to follow all applicable codes and regulations. This includes properly grounding the outlet and using appropriate connectors and fittings. Grounding is essential for electrical safety, as it provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electric shock. Proper connections and fittings are also crucial to ensure that the wiring is secure and reliable. If you are not comfortable working with electrical wiring, it is best to consult a qualified electrician. An electrician can properly install the central vacuum outlet and ensure that it meets all applicable codes and regulations. They can also help you troubleshoot any electrical problems that may arise. Furthermore, the NEC addresses the installation of central vacuum systems in various articles. Article 400 covers flexible cords and cables which are relevant to the direct connect hoses used in some central vacuum systems. This article specifies the types of cords that are permitted for use in different applications, as well as the requirements for their installation and protection. Article 410 addresses luminaires, lamp holders, and lamps, which may be relevant if the central vacuum system includes any integrated lighting. This article provides requirements for the installation and wiring of luminaires, including those used in vacuum systems. Article 422 covers appliances, which is the most directly relevant article for central vacuum systems. This article provides specific requirements for the installation and wiring of appliances, including vacuum cleaners. It covers topics such as overcurrent protection, grounding, and disconnecting means. Article 645 addresses information technology equipment, which may be relevant if the central vacuum system is installed in a commercial or industrial setting. This article provides requirements for the installation and wiring of information technology equipment, including considerations for power quality and grounding. Article 680 covers swimming pools, fountains, and similar installations, which may be relevant if the central vacuum system is used to clean these areas. This article provides specific requirements for electrical safety in and around swimming pools and fountains, including the use of ground fault circuit interrupters, GFCIs. When installing a central vacuum system, it is essential to consult the NEC and follow all applicable requirements. This will ensure that the system is installed safely and correctly, and that it meets all code requirements. In addition to the NEC, there may also be local codes and regulations that apply to the installation of central vacuum systems. It is important to check with your local building department to determine if there are any specific requirements in your area. In summary, while it may seem convenient to connect a central vacuum outlet to an AFCI-protected circuit, the potential for nuisance tripping makes this connection less than ideal. The high inrush current generated by the vacuum motor can easily trigger the AFCI outlet, interrupting the vacuuming process and creating unnecessary inconvenience. By opting for a non-AFCI protected circuit, you can avoid these nuisance trips and ensure that your central vacuum system operates smoothly and reliably. Remember to always prioritize electrical safety and consult with a qualified electrician if you have any doubts or concerns. Furthermore, always ensure that the circuit is properly sized and wired to handle the vacuum system's power requirements. By following these guidelines, you can enjoy the convenience of a central vacuum system without the frustration of frequent AFCI trips. The decision to connect a central vacuum outlet to an AFCI versus a non-AFCI circuit ultimately depends on a balance between safety and convenience. While AFCI outlets provide enhanced protection against arc faults, their sensitivity can lead to nuisance tripping when used with appliances that generate high inrush currents, such as central vacuum systems. If nuisance tripping becomes a persistent issue, switching to a non-AFCI circuit may be the most practical solution. However, it is important to carefully consider the potential safety implications of this decision. Non-AFCI circuits do not offer the same level of protection against arc faults, so it is crucial to ensure that the wiring is in good condition and that all electrical connections are secure. Regular inspections of the wiring and outlets can help to identify any potential problems before they become hazardous. Ultimately, the best approach is to consult with a qualified electrician to determine the most appropriate wiring configuration for your specific situation. An electrician can assess your home's electrical system, evaluate the potential risks and benefits of different wiring options, and provide expert advice on how to ensure both safety and convenience. Also, consider the specific type of AFCI outlet installed. Some newer AFCI models are designed to be more resistant to nuisance tripping while still providing adequate protection against arc faults. These advanced AFCI outlets may be a viable option for use with central vacuum systems, as they are less likely to trip due to inrush currents. Another factor to consider is the age and condition of your home's wiring. Older wiring may be more susceptible to arc faults, making AFCI protection more critical. In homes with older wiring, it may be prudent to keep the central vacuum outlet on an AFCI circuit, even if it means experiencing occasional nuisance tripping. In this case, it may be possible to mitigate the tripping issue by using a power conditioner or surge protector that is specifically designed to handle inrush currents. These devices can help to smooth out the current surge and prevent it from triggering the AFCI outlet. The NEC is updated every 3 years, and each edition may include changes that affect the installation of central vacuum systems and the use of AFCI outlets. It is important to stay up to date with the latest NEC requirements to ensure that your electrical system is in compliance with the current code. You can access the NEC online or through your local library. You can also consult with a qualified electrician to learn about any recent changes to the code. In addition to the NEC, there may also be local codes and regulations that apply to the installation of central vacuum systems and the use of AFCI outlets. These local codes may be more stringent than the NEC, so it is important to check with your local building department to determine if there are any specific requirements in your area. By carefully considering all of these factors, you can make an informed decision about whether to connect your central vacuum outlet to an AFCI or non-AFCI circuit. Remember to prioritize safety and consult with a qualified electrician if you have any doubts or concerns. One helpful approach is to test the central vacuum system on both AFCI and non-AFCI circuits to see if nuisance tripping occurs. If the system trips the AFCI frequently, then switching to a non-AFCI circuit may be the best option. However, if the system operates reliably on the AFCI circuit, then it may be safe to leave it connected there. Another option is to install a dedicated circuit for the central vacuum system. This can help to isolate the vacuum system from other electrical loads and reduce the risk of nuisance tripping. A dedicated circuit should be properly sized and wired to handle the vacuum system's power requirements. Furthermore, consider the location of the central vacuum outlet. If the outlet is located in an area that is prone to moisture, such as a bathroom or laundry room, then it is important to use a GFCI protected outlet. GFCIs provide additional protection against electric shock in wet locations. If the central vacuum system is used to clean up spills or wet messes, it is also important to use a wet-dry vacuum cleaner that is specifically designed for this purpose. Wet-dry vacuums are equipped with safety features that prevent electric shock and other hazards. Finally, always follow the manufacturer's instructions when using and maintaining your central vacuum system. This will help to ensure that the system operates safely and efficiently. Regular maintenance, such as cleaning the filters and emptying the dustbin, can also help to prevent problems and extend the life of the system.